Hi, so we're going to talk about electron energy levels. So energy levels. The distance of an electron from the nucleus determines how much energy it has. The further away an electron gets from the nucleus, the more energy it's going to have. And so you can see that. You can see each of these rings. Sometimes we call these shells. But these are the energy levels. The first energy level is the one that's the closest, second, third, fourth, fifth, sixth, and seventh, and so on. N is a letter that we use that just stands in for energy level. Okay, so within each energy level, there are energy sublevels. And so the pattern kind of follows like this. First energy level, one sublevel. Second energy level, two sublevels. Third energy level, three. Fourth, four. Fifth, five, and so on. Now you'll notice that some of these are red and some of these are black. So we only actually end up using the first four sublevels because there's only 118 electrons in the largest atom that we have. And so because we only are dealing with 118 electrons as our maximum number, then we only end up using the F sublevels. Right, so that looks like this. So even though the fifth, sixth, and seventh energy levels do have more sublevels, we don't use them, so we're only going to be using up to the energy levels F and so on. So what are these sublevels? Well, they're the orbitals. So we talked earlier about these to just kind of introduce the concept. You have four sublevels, S, P, D, and F. S sublevels always come in sets of one orbital. P's come in sets of three, so you have three orbitals when you have a P. D's come in sets of five, and F's come in sets of seven. So each orbital can fit 2 electrons. So if we look at our first energy level, it contains the sublevel S, which contains one orbital. So there is just one orbital in the first energy level. And so each orbital can hold 2 electrons, and therefore the first energy level can hold a maximum of 2 electrons. The second energy level contains the S and the P sublevels, and so they contain respectively 1 and 3 orbitals, which is a sum total of 4 orbitals. And so 4 times 2 gives us 8, so the second energy level can hold a maximum of 8 electrons. The third energy level contains the sublevels S, P, and D, which contain 1, 3, and 5 sublevels respectively, for a sum total of 9 orbitals. So the maximum number of electrons that can be held in the third energy level is 18. Okay, so the fourth energy level contains the sublevels S, P, D, and F. And so that is 1, 3, 5, and 7 sublevels respectively. In all, the fourth energy level contains 16 orbitals, which times 2 gives you 32 electrons can be held in the fourth energy level. So the same pattern is going to continue for levels 5 through 7. Sometimes the sublevels end up overlapping different energy levels. And so we're going to look at that. Here we have our first energy level, and it has one sublevel. We call that the 1s. Then we've got the second energy level. It has the 2s and the 2p. Then we've got our third energy level, and it has the 3s and the 3p. And then before you get to the 3d, you actually have the 4s sublevel. So the fourth energy level and the third energy level are overlapping. So after the 4s, you have the 3d, and you've finished your third energy level. Then it goes the 4p, then the 5s, then the 4d, then the 5p, then the 6s, then the 4f, then the 5d, then the 6p, then the 7s, then the 5f, then the 6d, then the 7p. So you can see there's a lot of overlap. So electrons always fill up the lowest energy level first. So we're going to model this with gallium. Gallium has an atomic number of 31, which means it can hold 31 electrons as a neutral atom. So we're going to start with our first energy level, which contains an s orbital. S orbitals can hold a maximum of 2 electrons. And so the first energy level can hold a maximum of 2 electrons. And so I'm going to start by filling that up. I'm going to put 1 electron in, 2 electrons in, and now we have a completely full energy level with 2 electrons in the first energy level. Then we're going to go to the second energy level, which can hold a maximum of 8 electrons. We're going to put 2 electrons in for the S, and 1, 2, 3, 4, 5, 6 for the P. It is now completely full with 8 electrons and cannot hold any more. Now we're going to the third energy level. The third energy level can hold a maximum of 18 electrons. So we're going to put 2 in for the S and 6 in for the P. And now it is partially full with 8 electrons. At this point, we actually can't put electrons in the d orbital until we first fill up the 4s. So we're going to skip the 3d and go to the 4s. And so the 4s can hold a maximum of 32 electrons. We're going to put 2 electrons in for the s orbital. And so the 4s orbital is now full with 2 electrons. The p orbital, d orbital, and f orbital of the fourth energy level are empty. Now we're going to go back to the third energy level because it only is currently holding 8 electrons, but it can hold a maximum of 18. And we're going to put in the remaining 10 electrons to fill up the third energy level. And so those will go in the d orbital. And so now our third energy level is full with 18 electrons. If you do a quick math check, we've got 2 plus 8, which is 10, plus 18, which is 28, plus 2 is 30. So we've got 1 more electron left. And so we're going to go back to our fourth energy level, and we're going to add in that final electron. And so now you can see here that the P is partially full with 1 electron. It can still hold more, but it is partially full. And that is our last electron that we had to put in, so we're done. So how do electrons fill the orbitals? Well, the electrons will fill up the 1s, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s, then the 3d, then the 4p, then the 5s, then the 4d, then the 5p, then the 6s, and so on. So we're going to look over an easier way to remember this. So first off, you're going to write out the following. So you just start at the top, write 1, 2, 3, 4, 5, 6, 7. Then put in S's. Then you go and you remember the second has 2, the third has 3, the fourth has 4. After that point, you're going to kind of start working backwards. So the fifth has 4, the sixth has 3, and the seventh has 2. Put in P's for the second column, D's for the third, and you can put in F's for the fourth column. Now you're going to draw diagonal arrows down to determine the order that electrons will fill the orbitals. So that looks like this. You draw an arrow through the 1s because electrons go there first. Then they go to the 2s. Then they go to the 2p, then the 3s, then the 3p, then the 4s. Then they go to the 3d, 4p, 5s, then the 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, and 7p. And so this is a model that you can use to help you remember where the electrons will go next. And you should memorize this model so that you can use it to figure out electron configurations.